This is lesson 602, TaxiCab Geometry. TaxiCab geometry is very similar to Euclidean coordinate geometry because the points, lines, angles are all the same and they're measured in the same way. What is different is the notion of distance. In Euclidean coordinate geometry, distance is thought of as the way the crow flies, a straight line. In taxicab geometry, distance is thought of as a path a taxicab would take. So the black path from point A to Z is the Euclidean distance from A to Z, and we're used to solving that with the Pythagorean theorem. The red path is the taxicab distance from A to Z. There is only one Euclidean path from A to Z, but there are multiple taxicab paths from A to Z, and you can see those differences right here. This is like a staircase distance. You can imagine driving through a city. These right here are blocks. The roads don't cut straight through from A to Z. And here it's probably a bunch of one-way streets. Same thing here. He had to go around this big block to get to Z. The taxicab distance is defined as the sum of lengths of the vertical and horizontal distances from A to B, which makes sense because you're going to take the measure from in this segment and you're going to add it to the measure in this one, add it to the measure here, add it to the measure here, add it to the measure here, and add it to this last but not least measure. Okay, that's how it's going to work. So when you do that, this is what it looks like. This is what the formula looks like. Well, let me get my pointer down here to show you. It says t equals the absolute value of y2 minus y1 plus the absolute value of x2 minus x1. And now remember what absolute value is. That is, no matter what the number is inside those bars, it's going to be positive. Doesn't matter if it's a positive or negative number inside that grouping, it's going to be a positive number when you take it out. Now then, the logic behind that is if you think, how far is -5 from 0 on the number line? Well, if you count the units from -5 to 0, you're going to see 5 units. It's not going to be a -5 units because distance and length are not negative. They're always positive. That's what absolute value means. So the taxicab distance is defined as the sum of lengths of the vertical and horizontal distances from A to B. So your first step is to label your points. I always label my points. And I'm going to tell you what, I even labeled them getting ready for this slide, and I still plugged it in wrong. Okay, so you've got to be sure you label your points and pay attention to how you're plugging in your values. Your next step is to plug and chug, which means this step right here where I go ahead and I plug in 4 for y2, I plug in 2 for y1, I come over here and I plug in a 5 for x2, and I plug in a 2 for x1. And then the chugging part is this right here, where t equals the absolute value of 2 plus the absolute value of 3, and t equals 2 plus 3, t equals 5. That's the chugging part. Now don't forget the absolute value because distance is never negative. Driving a cab backwards won't erase the miles. Okay, so think of it that way. So here in this line I said t equals absolute value of 2 plus absolute value of 3. Well, the absolute value of those numbers are going to be 2 and 3, so it works out pretty good. But right here, if this had been a -3, I still would have made it a +3 when I got to the next line. So the taxi distance from A and Z is going to be 5 blocks. the taxi distance between A and Z is 5 blocks. So that's what the taxi cab driver is going to charge you for. Okay, 5 blocks. Now, taxi distance is different in Euclidean and TaxiCab geometry. The circle is defined. I should have put the taxi distance in circles is different. I was thinking, why is it different? Okay, the circle is defined in the same way in each of them. So here's the Euclidean. It says the set of all points are equidistant from a single point. It says in Euclidean, the circle is defined as the set of all points that are a distance of 3 from A in this particular picture. They could be, if you look up here at this other definition, it says the set of all points that are equidistant from a single point. So in this illustration right here, all the points are a distance of 3 from point A. That's defining our circle there. So in taxicab geometry, the circle is also defined as the set of all points that are a distance of 3 from A. So, but you look and you say, wait, we don't have a circle there, we have a square. That's right, because no matter how if I start at point A, no matter how I draw 3 blocks, I'm always going to end up, so if I go up 2 over 1, 3 blocks, up 2 over 1, 3 blocks. If I go up 1 over 2, that's 3 blocks. Anyway, and when you connect all those dots for 3 blocks, it comes out looking like a square, not a circle. So let's draw a taxicab circle with a radius of 8. There's our center. That's where we're starting out at. If I go 8 blocks to the left, that's where my new point's going to be. If I go 8 blocks to the right, that's my point. If I go 8 blocks up, there's my point. If I go 8 blocks down, there's my point. I'm wondering if that's really 8. It looks pretty long. 1, 2, 3, 4, 5, 6, 7, 8. It is 8, but it looks like it's longer than 8. All right. Now the thing is no matter how I choose to go 8 blocks, I will always end up at points that will line up for a square. So if I was to go up 2, over 1, up 1, okay, that's 2, 3, 4. Then I'm going to go over 2 more, that's 5, 6, and I go up 2 more, it's going to be right here. That is a point that lies between these 2 outer points. So no matter how you calculate 8 blocks, it's going to end up making this look like a square. So what I'm going to do, I'm going to add that side. I'm going to add that side, then this one, and then this one. Now look here. If I went 4 this way, and then I want 1, 2, 3, 4, it's always going to end up on one of those points. I just think that is so cool that a circle in taxicab geometry is actually a square. That's why it's called non-Euclidean geometry, by the way. And that's pretty much it for this lesson. Your, what do you call it? Your problem sets still need to be done, and it's pretty easy problems, and get that quiz finished if you haven't already. That's going to be it for this lesson. Thanks for listening.